Hi everyone, welcome to another R tutorial video. In this tutorial I'm going to continue exploring the NBA dataset and I'm going to show you how to do some high-level statistical summaries of this data. Let's start off, as we always do, by loading in our datasets. And I'm going to format that game date field. I've already done that. I'm also going to subset our dataset so that we're only looking at regular season games, not all games, using that playoff indicator function. And also I'm going to load a library called Plier. This is a library that I've used in previous videos, but just to remind you what it does, it helps you manipulate and shape your data so that it could suit your analysis needs. That's a really high-level description of what it does, but basically if you need to summary your data one way or you need to reshape it another way, Plier is a great package to help you do that. So I'm going to load that. Then, as usual, as typical, I'm going to do the head and the name functions. And I'm going to start off by using this Plier package right away. Okay. And the function I'll use is the Plier function. The first argument in here is the data frame that I want to manipulate. Next, I write in the fields that I want to summarize by. The player and the player ID field. The reason that I want to group by the player and the player ID field is because there might be a situation where two different people have the same name. One player could be named John Williams, a second player could be named John Williams, and I don't want to group those two people together. I want to keep them separate. The way this data set is created, individual people, even if they share the same name, will have a different player ID. So I'm going to take advantage of that here. But I also want to include the player field because normally we refer to people, basketball players, by their names. So if I need it, I want to have the player ID, but typically we refer to players by their name. Next, I'm going to use the summarize function, and this is a built-in function that's part of Plier. Plier will group things by a common field. That's what that second argument does. But I also need to use the summarize function so that I could perform some functions on some other fields in there. And well, it'll be a little bit more clear once I actually run this function. But this is, I guess, just for now, just if you're going to do the Plier function and perform some summarizing calculations, you're going to need to use this. You're going to need to have the summarize function in the Plier function. Okay, so I have summarize there. Next, I want points per game. And points per game, if you think about it, is just going to be the sum of the points. Points is a field in the all underscore data frame. Oh, and I just noticed a mistake. I want regular season games, so instead of all underscore df, I'm going to use rs underscore df. Okay, so anyway, points per game is simply going to be the sum of the points divided by the sum of the games played. And I'm going to toss in another function here too. I'm going to do standard deviation of the points. Basically what I want to do here is I want to get an idea of how consistent a player is in the number of points that they score. So I'm going to run this, use several lines of code. By the way, the reason that I'm indenting like this is it's not that R requires it. It's just I think that it's going to make it easier to read in the long run. And let me explain that. Let's look at line 12 and line 9. Notice that I have two parentheses here. And if you look at the indentation of line 9 and line 12, notice that it's at the same level. The reason that I decided to indent like this is even if I look at this 6 months from now and I start looking at my code, because I have a certain indentation style and I read this, I'm going to know right away that everything at line 9 and everything at line 12, everything within there is kind of like a in between those two parentheses. I can look at the indentation right away and realize that I can look at line 10 and line 11, see that they're indented even further, and I know that they're contained within those parentheses. So basically, it's just a way to make it much easier for me to read in the long run, if I have to read this, several months down the line. It also makes it easier for someone else to read. Once they kind of figure out what your conventions are, it makes it much easier for them to read. I could have written this all in one line, but it would have been a very convoluted mess, to be honest. So that's the motivation behind that indentation. So I indented here, everything be contained within the parentheses is indented even further, and if I need extra room, then I simply return to the next line. And actually I need a comma here, I'm noticing as I'm reading this. So I need a comma there. I'm going to do a quick check, and it looks like I have commas everywhere that I need them to be. Okay, now I can run lines 8 through 12. So let's start this. Oops, it's not the plier function, it's the ddply function. So it's part of the plier package, but the name of the function is ddply. So everything that I mentioned before about the arguments of the plier function, that should actually apply to the ddply function. The ddply function is part of the plier package that I loaded earlier. So let's do that. Okay, so I have a data set called rs_liters, and let's take a look at this data set. And there we can see we have the player and the player ID and the points per game and the standard deviation. One problem with this, it's not necessarily a problem, but what our original intention was to look at the points per game leaders. And this is simply organizing everybody by, it looks like alphabetical by player name. So what we want to do is we want to order this in some way. So we can take advantage of the order function, one of the built-in functions in R. Also, we notice when we use this head function, it's only giving us the top 6. That's what the head function does by default. Let's say we want 15. So I'm going to have comma 15 here before I do any ordering of the rs_liters data frame. So I have the 15 there. That'll give me the top 15. Next, I have the order function, and I want to subset the rows. So I'm going to use the before the comma order. And I want underscore rs_liters $ points per game decreasing equals true. And let's think about what this is going to do. It's going to look at the points per game. It's going to rank them, but by default it's going to rank them from smallest to largest. Typically we think of the leader as having the most points per game. So I'm going to use the decreasing equals true argument here. So what this should do is it should give us the top 15 points per game leaders in the NBA. And let's run that. And, well, there we have it. And, well, we have, let's commit, a couple of these records to memory and then compare them with the actual results. Carmelo Anthony is the number 1, and he has about 28.7. Kevin Durant is number 2. He has 28.1. Kobe Bryant is number 3. He scores 27.3 points per game in the previous season, and LeBron James is one we've already checked. So let's go to our actual data set and look and see Carmelo Anthony 28.7, Kevin Durant 28.1, Kobe Bryant 27.3. And if we check the remaining records, we would see that the points per game indeed matches up. So this is great. We took our data set and we were able to validate it against the actual verified data. What's great about what we did is we were actually able to perform an additional calculation that, as far as I know, you really can't find online. And that is the standard deviation and how many points per game that they actually scored. And something that was really interesting to me, and it's something that I didn't really realize until I analyzed this data set, is, well, look at Carmelo Anthony's standard deviation, 9.1 points per game, and look at LeBron James's standard deviation, 5.8 points per game. That's actually a pretty big difference. There's basically a lot of uncertainty in, when Carmelo Anthony enters a game and starts, putting up points, and when LeBron James enters a game and starts putting up points. Carmelo Anthony really is kind of a situation where you don't know if he's going to score, 12 points in a game or if he's going to score 48. He could, have a mediocre night, or he could be absolutely on fire. Meanwhile, LeBron James, he's never going to, at least in the 2012-2013 season, he was never going to have, like an amazing night, where he, scores like close to 50 points or something like that. But he was Mr. Consistent. You could always count on him to have, around, 25 points per game, and within a very narrow range, he would put up those numbers pretty consistently, at least on the points per game side. So I think it's really interesting that we are able to analyze this NBA data in a way that I really don't think many people have really analyzed it before, looking at the standard deviation and points per game of individual players. And keep in mind that you can do this really for any statistic that's in the NBA data. If you want to do this for assists, for rebounds, for block shots, steals, whatever kind of statistic, you have the information there to do it. You can even break it down by month if you wanted to. If you wanted to look at the standard deviation in points before the All-Star game versus after the All-Star game, it's very easy to do that. You have all the information in this data set to be able to do that. And we're going to be doing a lot of that, plus much more, in later videos, but I just wanted to give you a taste of that for now. I'm going to leave the video at that. I'm going to leave the lesson here. Excuse me, let me start over. I'm going to stop the lesson for now. In the next video, though, what I want to do is show you a little bit of the data visualization side. Specifically, I want to show you how to really display to somebody who might not have a statistics background, really what it means for Carmelo Anthony to have a wide standard deviation and what it means for Kobe Bryant to have a much narrower standard deviation. So I'm going to show you some visualization techniques in R to help accomplish that. But that's it for now. Hopefully I'll see you guys next time. Bye.